Today we are going to solve systems with substitution. Today we're going to solve systems with substitution. So a little bit different than we did last class. We're going to solve systems with substitution. This is what the notes look like. It's day 7. Solve systems with substitution. So there are reasons or advantages to the different methods that we use. We talked last class about graphing, and then today we're talking about substitution. So depending on what form your equations are in, can kind of help like which one's going to be faster or easier. Let's go ahead and put our phones away. Let's go ahead and put our phones away so that we can do our math. So an advantage to graphing would be when one or both equations are written as y equals or in blank blank form. Do y'all remember what kind of form that is? Y equals mx plus b. Do y'all remember what that form is called? Y'all remember what that form is called? That is called slope-intercept form. Slope-intercept form. So if your two equations are in y equals, then it's slope-intercept form. So let's go ahead and take our phones off of our desk so that we don't have temptation. So take your phone and let's put it off of our desk so that we aren't tempted to get it. So let's take our phones and take them off of our desks so there's no temptation. Thank you. An advantage to using substitution would be if you already have an equation that's either x equals or y equals. And so if one of the equations is already written as x equals or y equals, then sometimes doing substitution is faster than graphing. So today, what method are we talking about? Today, what are we talking about? You can read the title. Substitution. Today we're talking about substitution. So here, just like the name implies, when you use the what method? What method are we learning about today? Substitution. Just like the name implies, when you use the what method? Substitution method. So the slope-intercept form, that is for graphing. That's what we did last time, graphing. That's graphing, last class. So if we're using the substitution method, you will blank to solve. What are we going to do? Substitute. To solve for one variable. Another way to think about substituting, we're going to plug in. That's what we're doing. We're plugging something in. That's substituting. Then you will blank again. What do you think? Substitute. I missed some letters there. Don't copy me. Substitute. We will substitute again to solve for the other variable. The solution all day, every time, doesn't matter. The solution every time, doesn't matter what method. The solution is the coordinate. It's the point of intersection. So it's always X and Y. And when we put them together, it's X comma Y. That's our answer. The solution, that's our answer where they cross. Are y'all glad that it's a 3-day week? Me too. Me too. Let's pause for a moment. Let's play some Family Feud. Let that sink in. Let's see. Y'all are at... Jaden doesn't want to play. Does anybody want to play? Or do y'all want to keep doing math? We can keep going. Yeah, why are you breathing so hard? Why are you so cranky about it? He says, listen, I'm a math man. I only want to do math. No time for fun and games here. You guys are sitting at 1573. You're holding second. My first period is extremely competitive. So if y'all could beat them, that could be awesome. Name something that might be made out of rubber.
Well, no.
Did I spell that wrong?
Sorry, you already put tires. Boom. Oh, that's nice. Well.
Those are all good answers.
Let's see what probably just said was a good answer.
I feel like a rubber ball is good.
Boy. Lost 10, boy. Might be Jordan. Oh, wow. Somebody said we said bands.
That is crazy.
That is.
Sorry, guys. I failed you. That's cheap. That's cheap. Okay, let's go. Question number 1. Is one of the equations as either X or Y equals? The first one is what equals? Y equals, okay. So that means we should use substitution method. It will be easier for us. So what we're going to do is it says that Y is equal to this stuff. Okay, so I'm going to take that stuff and I'm going to plug it into the other equation wherever I see Y. I'm going to plug it in right here. So I'm going to rewrite my second equation. And I'm going to leave myself space to plug in that stuff. I just substituted it. I plugged it in. So the first thing that we did was substitute. And now we're going to solve for X. Okay, so now we're going to solve it. To solve it, what do? This is what we did when we first got in here. So what do we want to do? We want to solve for X. What do we have to do first? Yep, we got to multiply. So we've got -3 times 2, so -6x. That's our first one. -3 times 2 is -6, and there's an x. Negative times a negative is a positive. And what's 3 times 3? 9. Next step, I have 2 x's. Can I put them together? They're on the same side, so I don't change any of the signs. I'm just putting these things together. So I have 4 minus 6. Or -6 plus 4, either way. -2x plus 9 equals 5. This is a 2-step problem. 2 steps, 2 things by the x, 2 steps. So what do I take care of first? The 9, very good. So I need to subtract 9. So what is 5 minus 9? -4. And I have one last step. Divide. Divide by -2. What is a negative divided by a negative? Positive. And what's 4 divided by 2? So I just figured out what my x is. Now I'm going to take my x. Okay, so I solved, and now I'm going to plug in x equals 2 to solve for y. We need to know what y equals. Which equation is going to be easier for us to plug into because we want y equals? The first one, it's already has y equals, so let's plug into that one. So if I'm going to plug into that first equation, so I have y is equal to 2x minus 3. So now I'm going to take this x is equal to 2 and plug it in. What's 2 times 2? What's 4 minus 3? Y equals 1. Our solution is always going to be x comma y. So we have to put it in that form. 2 comma 1. That is my solution. Let's please put our phones away. Next time I ask, we're putting phones on the wall. Doesn't have to be like that. So the next problem is one of the equations already as x or y equals. Yeah. So we already have x equals. So let's take this and plug it into the other one. I'm going to take that and plug it in. So I'm going to rewrite that top one, -2. I'm going to leave myself space plus 4y is equal to 0. And I'm going to plug in that stuff. 3y minus 5. So again, my first step is to substitute. Not a 3, 2. First, we're going to be solving for what? What is the variable we have now? It's y. It is y. What we're left with when we plug it in, we only have y's. So we have to first solve for y. When we do that, what are we going to have to do first? We're going to have to distribute. So we have -2 times +3. Negative times a positive will be a negative. And 2 times 3 is 6. And there's a y. And if at any time you want a calculator, no shame in that. Get you a calculator. The next one, we've got -2 times -5. Negative times a negative is a positive. 2 times 5 is 10. Just like before, we need to combine like terms. I have y's on the same side, so let's put them together. I have -6 plus 4. What's -6 plus 4? I'm putting these things together. They're on the same side, so I don't change any signs. So I have -2y plus 10 is equal to 0. This is a two-step problem. What do I do first? Move the 10. So I'm going to subtract 10. Last step. What is my last step? Divide by -2. What happens when you have a negative divided by a negative? Positive. Very good. So I have 10 divided by 2. 10 divided by 2. What do I get? 5. All right. My solution is going to be an x comma y. I already have part of my solution. I already have the y part, so I can put it in there. It's going to be a 5 down here. So I already know half of my solution. It's y is equal to 5. Goes in there. So my next step, now that I know what y is, we're going to substitute y equals 5. Solve for x. So which equation do you think we should plug into that would be easier to solve for x? We want x equals. Yeah, let's plug into that. You can plug it in technically into either equation, but why not plug into the second one? So the second equation is x is equal to 3. I'm going to leave a space for the y minus 5. I'm going to take that y equals and I'm going to plug it in right there. What is 3 times 5? 15. What is 15 minus 5? 10. Very good. So this is my x. My x equals 10, so I can plug it in here. That is my solution. The x and the y. Which method do y'all like better so far, graphing or substitution? Usually it's split. Some people like one more than the other, and it's fine. Whichever way you like better. Sometimes it's easy. One method's a little easier to do than the other, but really any equation, you can do either one. Okay. Let's play another round. Double points. Name something you might judge by how good it smells. I agree with that one. I think that's solid. If somebody stinks, you might judge them. I know. I'm trying to think of ones that would be good for us to put in. I put that one in. I feel like they're very obvious.
We said person.
We exactly typed it in like that as
Why?
person. That's not really fair. Take the pass. The next question. Do I have one of the equations that's either x equals or y equals already? Yeah, the second one. It's already x equals. So we can take that stuff and plug it in right there. To do that, I rewrite the first equation. So it's 2, I'm going to leave myself a space, minus 12y is equal to 3. Now I'm going to take and I'm going to plug in that stuff. 6y plus 9. When you do this step, that very first step, if you plug it into the wrong equation, what happens is that you have both x's and y's, and that can't help you solve for anything. So you got to make sure that you've got just one variable when you do this part. So what's my first step now? I've got to solve for y. I'm going to have to distribute. Very good. So I have 2 times 6. And there's a y. 2 times 9. All right, just like the problems on the front, I have 2 y values. We need to put those together. When I put them together, what is 12 minus 12?
Why?
Well, what's 12 minus 12? Y'all are saying it. Yeah, so do I have y anymore? If I have 12 and I take 12 away, how many y's do I have? None. Like that cancels. So what I'm left with now is 18 is equal to 3. Is that true? No, not in any world. That is not true. We call that a false statement. What is our answer when we get false statements? No solution. So there's a table that comes next, and these are special solutions. So special solutions are when your variables cancel out. That's what happens here. My variables canceled, and then I'm left with some math statement. If it is false, there is no solution. So a false statement, give me an example, and you could give me the one we just did. What's an example of a false statement? 18 equals 3. That one works. Sherry Parmenter. Honor? Sure. Thanks. So when this happens, 18 equals 3, and we know that is not true, we say no solution. There's also the empty set. You can use that symbol as well. Either one. Either one of those work. A true statement. Give me an example of a true math statement. No variables. A true math statement. The variables disappeared. What? 3 equals 3. That is true. What is our answer when we get a true math statement? Infinitely many solutions. Infinitely many solutions. We are almost done. Let's finish up our game. Name something people swallow without chewing.
Hot dog. Hot dog. No.
Who does that? I don't think that's correct. Hello? I do. I will. Rebecca, you are leaving. I'm just trying to guess things that might be. Hello, you're gonna have to wait while we finish our game. You can contribute. I think this is gonna be easy.
That's true, that is true.
That's
Money,
fast money round. They look like snot, so I'm not having it. Name something adults take lessons in. Name a place dogs are known to drink from. Name something you clench when you're stressed out.
Yes.
Name an animal that's easy to intimidate in charades. Name the occupation of someone you make an appointment to see when you need to get something off your chest.
Dancing is related to parenting.
No, it's saying that's another possible answer. Or it's actually giving us the first answer.
Dang, that was.
Y'all didn't make an epic comeback, so we're gonna keep your score.
Well, let's compare those 2 rounds.
Yeah, that was kind of cheap.
This is fun.
I am not sure. I haven't worked it. That's why it says compare with yourself. Did you compare with your people?
I was talking with Sullivan. Sullivan said it's some because he was talking about like it's skipping or something, which makes sense. I have no idea.
Okay. Well, I would check with a few more people. Ask around, see what they say. I would say that if you get 3 consecutive people that didn't work with Sullivan, that get something confirming either one of you. We're almost done. Just because the directions say to use the substitution method, it doesn't mean that you're ready to substitute. Sometimes you have to make a small adjustment first. Okay. When we look at the next problem, is either one of them or are either one of them already in X or Y equals? No. Well, is one of them really easy to get that way?
Yes.
Which one? Yeah, this one, it has a Y and there's nothing attached to it. So really all we would have to do is move the 2X to the other side and then this one's ready, right? So that's like a small adjustment that we have to make. So for this one, if we brought this 2X to the other side, subtract 2X, now we have Y is equal to 5 minus 2X. That is in Y equals form. So we can take that and we could plug it into the other equation where we see Y. So let's do it. We have 6X plus 3, I'm leaving myself a space, equals 15. So I'm taking that and plugging it in. Five minus 2X. What's my first step now? And it's really our first step for every problem we've done. We did substitute, yes. And now once we're solving, what do we have to do? Distribute. I didn't do anything with this 6X. So 3 times 5 is 15. 3 times negative 2, negative 6, and there's an X. I see two 6s and I need to, or sorry, two X's and I need to put them together. What happens if I have 6 minus 6? I don't have any of those anymore. So I end up with 15 equals 15. That is true. What happens when we have a true math statement? Infinitely many solutions.